Welcome, guys. Today we will be continuing our discussion into the Pythagorean Theorem by working on a problem that I call spiraling triangles. First, before we start, let's observe the shape here. We realize that on the outer circle, each side has a length of 1. We also realize that, of course, these are all right triangles, and moving counterclockwise from the first triangle circled in red here, the leg of every triangle is always the hypotenuse of the previous one. The leg I'm referring to here is the one that is not on the outer circle of the spiral. With these observations made, let's see if we can figure out some kind of pattern. Let's set up a function here of fn, function n, with n representing the nth triangle in this spiral. Counting counterclockwise from the first one, and fn will act as the hypotenuse of that nth triangle. Starting with the first triangle, which is a right isosceles triangle, with both sides having a length of 1, that is, both sides that are legs. Here, n will be 1, so f1, using the Pythagorean theorem, will be root 2. As we've discussed above, root 2 now becomes a leg of the next triangle, with the other leg being 1. This is the second triangle, so n is 2 here, and f2 is root 3. The next triangle has legs of root 3 and 1. So the hypotenuse of it is f3, which would be root 4. We know that root 4 is 2, but we'll just leave it with the square root sign for now. Time to look at everything we've just completed. f1 is root 2, f2 is root 3, and f3 is root 4. We realize that whatever n is, the fn corresponding to n always has a value where the number inside the square root sign is 1 more than n. And you can always go and try to prove this on your own. For now, though, let's express what we just said using an equation. Well, we can say that fn is equal to the square root of n plus 1. On the screen here, I have just made it clear how I got to this conclusion. By now, we've surely done enough profiling. Let's refer back to the problem. All it asks is for us to find the value of x, which is a hypotenuse of the final triangle in the diagram. Well, in order for our formula of fn to work here, we have to figure out the n here. So which triangle this is? It's the 15th triangle. Therefore, x is equal to f15, because x is basically the hypotenuse of the 15th triangle. Solve for f15 using the formula. f15 is the square root of 15 plus 1, so the root of 16, which is 4. Therefore, x is 4. There we go. We have completed this problem. Hopefully this video has helped to enhance your understanding with the widely used Pythagorean theorem. Please like and subscribe, and see you next time.